Hello everyone, welcome back to my channel. Hope you all must be doing well. In this video, we are going to discuss about IoT architectural reference model. Let's start the video. This model consists of 7 layers and it was published by IoT World Forum Architectural Committee in 2014. This model helps clarify how IoT systems should be designed and how various components should work together. Now, using this model, we are going to achieve what? We will see that first. It will decompose the IoT problem into smaller parts, identify different technologies at each layer and how they relate to one another, and also define a system in which different parts can be provided by different vendors. It will also have a process of defining interfaces that lead to interoperability. Let's see each layer in detail. Layer first is physical devices and controller layer. This layer is home to the things in IoT, including the various endpoint devices and sensors that send and receive information. The size of these things can range from almost microscopic sensors to giant machines in a factory. Their primary function is generating data and being capable of being queried or controlled over a network. Examples include sensors, actuators, devices like smart thermostats, cameras, and wearable devices. See second layer, that is connectivity layer. This layer mainly focuses on connectivity and its most important function is reliable and timely transmission of data. More specifically, this layer includes transmissions between layer 1 devices and network and between the network and information processing that occurs at layer 3, which is the edge computing layer. Now examples includes wireless networks like Wi-Fi, Bluetooth, Zigbee or cellular networks, wired communication via Ethernet or gateway devices that aggregate data from sensors and forward it to the cloud. Let's see layer 3, that is edge computing layer. This layer provides local processing, filtering and analysis of data closer to the edge, that is the source, rather than sending all raw data directly to the cloud. It helps reduce the latency of decision making and the bandwidth required to transmit data to the cloud. Now the examples includes local processing of video streams by smart cameras, edge analytics performed by IoT gateways or routers before sending data to cloud platforms, fog computing platforms that perform local decision making for smart city applications. Let's see layer 4, that is data accumulation layer. This layer is responsible for collecting, normalizing and aggregating data from the lower layers. It gathers data from various devices and communication systems and it also ensures it is in the usable format and prepares it for the storage or further analysis in the cloud. Now the examples includes data brokers and middleware platforms that aggregate data from sensors and edge devices, message queuing services like MQTT brokers and data streams over Kafka, cloud-based data collection services like AWS IoT Core or Microsoft Azure IoT Hub. The fifth layer, that is data abstraction layer. This layer mainly focuses on organizing, managing and abstracting the data collected from lower layers to make it usable for analysis and decision making. It involves processing raw data into formats that can be easily queried and understood. It also provides data storage and management. Examples includes cloud databases, distributed file systems, storage services like AWS S3 or Google Cloud Storage, middleware that transforms raw data into usable formats for analysis and reporting. Now, the sixth layer is application layer. It represents the interface where users and organizations interact with IoT system. It includes applications and services that deliver value to end users, whether it is monitoring, control, data visualization, or automation. This layer also focuses on analyzing the data accumulated and processed by the previous layers. It applies data science AI/ML techniques to extract insights, detect patterns, and make decisions based on the data collected from the IoT devices. Now let's see what are the examples. Predictive analytics in manufacturing, analyzing sensor data to forecast equipment failure. Real-time analytics in traffic management system. A mobile app to control smart home devices like lights or security systems. Industrial control systems monitoring factory equipment through a dashboard. Smart city applications allowing administrators to monitor traffic flows, energy usage, or waste systems. Now the last layer is collaboration and processes layer. This layer consumes and shares application information. Collaborating and communication IoT information often requires various steps, and this is what makes IoT useful. This layer can change business processes and delivers benefits of IoT. Now here comes to an end of this video. If you have any queries, do let me know in the comment section. If you really like this video, do let me know, and please like and subscribe to my YouTube channel. Thank you so much.